and although this is related mainly on hydrate, but can be used on other areas. This is a project that we started some 15 years ago, and we support the major oil company like BP, Dong, Gulf the Suez, Total, Scottish Enterprise, Statoil, Petronas, and Chevron, and Hydrafact. Now, one question here for you all. Which one of these applications is relevant to you? Because HydraCHEK can be used in all of this. If you are interested to make sure that the amount of inhibitor is enough, not too much, not too little, Goldilocks principle. We want to make sure we have enough inhibitor, not too much, not too little. We can achieve this by HydraCHEK. The other application is that, for example, low dosage hydrate inhibitor is poisonous. Therefore, the concentration of this compound can be important in disposed water, because inhibitor can either be recovered or disposed. If it is recovered, it is important to know how much is in the inlet water, in produced water, and what is in the disposed water. So that is important. If the company cannot recover KHI or LDHI, it is important to know how much this material we are disposing to the environment. Another important point in this water breakthrough. Normally, reservoir initially produces the condensed water, which is basically a still water. The water which is converted from water vapor in gas phase and converted to water. But when we have water breakthrough, that is water is coming from reservoir in the liquid format. So it has salt. And this is called water breakthrough. That can cause a lot of problems because you need to be careful of the corrosion. So it is a sort of breakthrough in water breakthrough. The other application that some places we don't know how much we are producing water. We don't know. So one option, we know how much inhibitor we are injecting in the produced water to prevent hydrate formation. From measuring the concentration of inhibitor in the produced water, we can estimate the amount of produced water. So we know how much water we are producing. That can be very crucial. Another process that can be used is the ability of regeneration of milk regeneration unit, because milk regeneration unit, we have rich milk injected to regeneration unit and produce lean milk which doesn't have too much water, and we can monitor the efficiency of that process. Do you have something like this? I know that some of our clients, they want to also measure the efficiency of milk regeneration unit. Another application is quality of chemical. That is, for example, umbilical. We inject the chemical, and if this chemical is off a spec, it can block the umbilical. And we have blockages in different places. We can prevent that by checking prior to introduction to umbilical by HydraCHEK. Or factory can check the quality of their produced water. Another application is application of HydraCHEK with multi-phase flow meter. Multi-phase flow meter normally use two physical property and material balance and find the three phases, that is water, hydrocarbon, and gas. The most difficult phase is water, because with the smallest chemical to water, it becomes very difficult to make sense of it. But with HydraCHEK, we can predict the property of aqueous phase, knowing the concentration of salt and alcohol in the water, produced water. The water which is produced and some chemical added to it. Please come back to us. We can have a lot more data here. Also, another possibility that can be used for changes in amount of salt content or inhibitor content, which can be an indication of hydrate formation. We know one of our clients use this technique to make sure the amount of inhibitor in produced water does not go above 10%, because for their system, up to 20% hydrate will not block the pipeline, and they put a limit of 10% hydrate formation. So any of these applications, and maybe more that I can think of, HydraCHEK can perform. So let's go now on the basic principle of hydrate. So hydrate form at low temperature and high pressure. It is a major flow assurance problem. Plug and maybe blockage of pipeline. Substantial operation and HSE impact. Now, chemical mitigation strategy is using chemical, either thermodynamic inhibitor or low dosage hydrate inhibitor. Some of these inhibitors are in the nature, produce water, but some of them we add, make ethanol, make and low dosage hydrate. One point that I want you to remember, the hydrate phase boundary. This is the hydrate phase boundary. Let me show you. Hydrate phase boundary. This line shows the hydrate phase boundary. Is controlled by two parameters: composition of aqueous phase and composition of hydrocarbon phase. Composition of hydrocarbon phase doesn't change with time, doesn't make significant change with time. So we can assume the composition of hydrocarbon is constant. So what is changing is composition of aqueous phase. And hydrate is like this. This is hydrogen bonding because of hydrate and water molecule, and then a gas molecule going into this. And the stability of hydrate depends on the size of this molecule. This green is the gas molecule. So there is a ideal size for size of the molecule, and that gives maximum stability. But the thing that changed suddenly is water phase. Why? Because you might have water break that can give a lot of salt in the system, or you inject inhibitor. You normally inject inhibitor based on your calculation, but the amount of water produced can be changed. That will change the concentration of water. So we control hydrate stability zone of the gas by controlling the composition of the aqueous phase. Now here, if it's let's see, yeah, this is hydrate formation. You see that at the interface between gas and water, hydrates has formed and block the path from gas to water. So a layer of hydrates form here, and then we don't have any more hydrate. That is can be a danger because during shutdown we can form some hydrate, but during a startup we can form a lot more hydrate. Now, I was thinking of where HydraCHEK can be used. So a typical pipeline, this is Ombalanga in Norway. You see that the main reservoir is around 1,000 meters below the sea level. And the temperature here is -2 degrees, could be -2 degrees. So the temperature here initially is high and then drop. And then as it comes to shallow water, it warm up. And here is outside hydration. So you see that the beginning and end of pipeline is outside hydrate region, but in the middle can be inside hydrate region. Or another field can be like this. Yeah. So different way of entering and exiting hydrate region. There are various techniques that can prevent it. We can prevent hydrate problem. Now, the oldest one probably is dehydration. And then I mentioned other point, controlling temperature, controlling pressure, and then injection of thermodynamic inhibitor, methanol, ethanol, glycol, using low dose hydrate inhibitor, kinetic hydrate inhibitor, antiagromanant, various combination, and cold flow. So far, we have tested, we see that the concept of HydraCHEK can be used for using thermodynamic inhibitor, kinetic hydrate inhibitor, and also dehydration. So these applications, we can design the HydraCHEK to be used for controlling hydrate, to determine where is hydrate phase boundary. So hydrate stability zone depends on hydrocarbon phase. I said that it doesn't change, and depends on the aqueous phase, salt and chemical inhibitor. Now, the other point we need to find hydrate safety margin is the pipeline condition. Pipeline condition, there are different options. We can have pipe simulation, different software. We can have actual measurement in the pipeline, or we can assume seabed temperature and pressure can be measured. So there are various options to plot this line. So now you see that hydrocarbon phase we have, only we need to measure aqueous phase. So you can say that we can take sample. Yes, we can take sample and send it to the lab. but it takes 12 to 24 hours. We want something online immediately so we can react, and HydraCHEK can do that. Within 5 seconds, HydraCHEK will tell you where, with respect to hydrate, you are. So even if you are using very safe processes, it can be uncertainty in the water cut. Maybe we don't know how much is water cut. We are injecting inhibitor based on assumed water cut. Maybe it's too much, maybe too little. Inhibitor partitioning. Some inhibitor, they partition in different phases. And the amount of partitioning in different phases depend on the condition and type of inhibitor. For example, methanol will go a lot on the gas phase. On the other hand, MEG go very little. KHI normally doesn't go to the vapor phase. So all of these become important. Equipment malfunction. Maybe a pump doesn't work. We need to know. Or we have human error. Yeah, human error. Somebody forget. Somebody open wrong valve, wrong pump. We had a case, pipeline block for 6 months because I'm sick. Changing system condition, temperature, pressure can change. And sometimes it's possible the inhibitor is off spec, that you're using wrong inhibitor. With the price of HydraCHEK, having an extra measurement device is good. Then you are sure you didn't waste your resources. So HydraCHEK, I have one in my desk here at the moment. So is a vessel like this with 100 cc of vessel that we can fill it with water, produce water. And then we measure electrical conductivity and temperature with this conductivity meter. And then we measure the speed of sound in aqueous phase. So we measure two properties. The interest point is that these two properties, they work against each other. And therefore, we can find the specific composition. So we measure electric conductivity, acoustic velocity in produced water. And with computer modeling and temperature, we can measure the amount of salt, KHI, inhibitor, MEG, methanol, everything. In fact, now we can measure 3 parameters. So for some places that we have basically buffer solution, then we can use the buffer solution as another unknown. So we basically we tune the model based on 15 to 25 Celsius. And from there, within 5 seconds, we determine the amount of inhibitor. Just real time. Then you can make a decision. No chemical, nothing. You just press a button. Then from knowing the aqueous phase composition, hydrocarbon composition, we can plot hydrate phase boundary. This is the hydrate phase boundary. From this hydrate phase boundary, we can say whether we are inside hydrate region or outside hydrate region. So if this is pipeline condition, if the hydrate phase boundary is shown here, some part of the pipeline is inside hydrate region. So there is a risk of hydrate formation. So we can have red light if you want, but it's clearly shown. And then if we are just matching to be outside, then it is low safety margin. So that is the condition now. Okay, but we don't have much safety margin. This is amber light. But if you, most company, they want 3 to 5 degree safety margin. So if we have 3 to 5 degree safety margin, this is safe zone. In effect, what happened, Total asked us to develop this system and they wanted traffic light. And then we said we add one button for you, one extra light. If you're injecting too much inhibitor, we have a blue light. So if you are wasting your inhibitor, not only will damage your budget, but also damage the environment. We can prevent that. Now, this is basically the final solution. We can find out if the system is in danger. We also have online HydraCHEK. This device will take the sample, we condition the sample by heating, by peltier element, by heating, removing emulsion, then cooling down between 15 and 25, and then measuring the concentration of salt and inhibitor, and then dumping it to storage or to the back to pipeline, and then rinse it, and then get ready for the next sample. That can give you around 30 minutes per sample, but it's up to you. You can measure 30 minutes. A lot of companies, they measure every 12 hours, they take a sample. But even if you are always safe, having an extra safety measure will be useful. We are now so successful that we want to develop something similar for wax, and we have good result. So basically, this is the whole system. That is HydraCHEK and our software, Hydrafact. Combining together, we can measure temperature, conductivity, velocity, and then computer program, sort, and getting the final result. This is an example that we have used different concentration of inhibitor, and we can use it something similar to uh, HydraCHEK. Even we don't have water, if we don't have water sample from the water in the gas phase, we can predict hydrate phase boundary. So in effect, we don't need water. But if we have water sample, it is more accurate. But from amount of water in the gas phase, we can predict hydrate phase boundary. This is the uh, basically how it is placed in the Pele case. And this is a whole shape. And this is some application. This is bit total in the North Sea. Initially, we reduced the amount of methanol from 28% to 5%. And then from 5% to zero. 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 No way has been talked about this. This was the case that they didn't have the facility to operate with methanol. So they noticed that up to 20% it won't block. And they put the limit of salt to 5%. And from increase in concentration of amount of salt from 4.5 to 5%, they realize that they are forming too much inhibitor. And here you can see this is the concentration of salt. This green line is around baseline is 4.75. Yeah. So when you increase it to 5%, it means that the amount of hydrate, because hydrate will exclude salt. So the concentration of salt in remaining water will increase. This is published SV. So we were able to give them 24 to 48 hours warning before hydrate blockage. It's roughly, I said, 4.5 and 5% presence of 10% salt increases the amount of salt to 5%. 12 to 48 hours. I mentioned the online HydraCHEK. More than 140 million Great Britain pound extra production, increasing the life of reservoir by 5 years. It's been applied many places. And if you are interested, I can send you the case studies. Some of them have been published for publication here. Again, if you are interested, I can send you the publication. And these are some feedback from different users. North Sea, another North Sea, Middle East, and Dolphin Energy feedback. South Pars gas complex, when the relation between Iran and West was good. Nugget used to be CV technique. And because of this device, we achieve extra 5 years production, more than 150,000 pounds. And it was huge success. And we got Queen's Anniversary Award for innovation in oil and gas sector for increasing productivity and reducing contamination. External production. And it was also recognized by chemical engineer. We went to Parliament and also REF impact case study in 2001. And this is the meeting, the audience we had with King Charles. And I mentioned the previous application. That is for HydraCHEK. If you have any question, please fire away. Thank you very much for your attention. چند نفر هستن؟ آره میخواه اگه دارن. اگه ندارن do you have any question?
I have a question.
Yes.
So one of the benefits of HydraCHEK, you said, is that you can get real-time results as
Yes.
opposed to having to send samples to a lab and waiting for it to come back. So how does HydraCHEK ensure the same level of quality of results?
Even better than the quality you have. It is because when you send sample, there is a possibility of contamination. There is possibility of evaporation. I don't see any problem. This is the accuracy of HydraCHEK is 0.2 weight%. Give it a go. Be our guest. We'll send you free of charge. Be our guest. More convincing. If you are interested, I can also talk about the other innovation we have. We call it HydraSense, that will detect early signs of hydrate formation. If you have energy, I can explain that one as
So what's the difference between HydraSense and HydraCheck?
well. HydraSense, HydraCheck will detect safety margin that how far away from hydro zone you are. HydraSense shows to you is if hydrous is forming, early signs of hydrous formation. Let me explain that, okay? I try to be as short as possible, okay? I explain to you very quickly. So, detecting early signs of hydrate formation. If you look at pure compound, their hydrate formation potential. This is for H2S. This is H2S. This is IC4. This is C3. This is ethane. This is methane. This is, I think, CO2. This is CO2. This is nitrogen. Which component is more likely to form hydrate? Which one has higher affinity for hydrate formation? H2S. See that? This is IC4. The next one is IC4. Then C3. So when hydrates form, you would have more, if we have H2S, you would have more H2S in hydrate structure. And then less IC4, then less. This is another, this is less ethane, then CO2. So you see that the composition of hydrate is different the composition of the gas. So when hydrates form, we will see the change in composition in the gas phase. And because gas is the fastest moving phase, you should be able to see it. You might say, oh, a little becomes yet, but I'll explain what trick we use to see it. This is prototype of HydraSense. Another one, picture. It is a real composition, real device. Here we are using an online GC. This is gas PT. This is recognition. This is filters and the rest thing that goes to GC. It has been also tried. Total has been published. I can send you the paper. Uh, Total has a reservoir in body of in the mainland of France, and the water got increased, and they couldn't cope the amount of water, amount of methanol they need. So they decided to use anti-agglomerant and then use an online gas chromatography to monitor the composition. They come back to us with this figure. You see that initially is not really clear, but you see the whole year they have around 8-10 days they are in the region of hydrate. When hydrates form, more C3 is used than C1. So this ratio goes up. And then when melt, then form again, melt, form again. And this is repeated for RC4. So we can detect hydrate formation. And the whole year, they needed these 10 days for preventing hydrate formation. But they were using anti-agglomerant for the whole year. So we can detect hydrate formation. Remnant of the hydrate structure will remain in aqueous phase. And then we can detect when they melt. So here we see initially gas hydrate formation here in the gas phase. So the first sign of hydrate formation is here. But also we can detect where is hydrate forming. For example, if we know the slip velocity is velocity difference between gas phase and water phase or liquid phase. Gas will show hydrate formation very quickly. But then some hydrate which has deposit in the water comes out and go to water degas. Now here we see the gas coming out of the water resulting from hydrate dissociation. So if we see the sign of hydrate formation at time 0, and then gas resulting from hydrate dissociation at time 1000. If the slip velocity is 10 meters per second, it shows that hydrate formation is happening 10 kilometers away. So we can detect where this hydrate forming. Then we can decide whether depressurization is better or injection of inhibitor. So this is the whole loop. The sign from hydrate formation in the gas phase, come here. The sign from water melting or hydrate melting, come here. This comes at time 0. This is at time 1000. Imagine the velocity of water is 5 meters per second. Velocity of gas is 15 meters per second. So we can detect where is hydrate from. And combination of the two, HydraCHEK and HydraSense, will give a powerful system for you. It is, you can extreme your test. You can reduce the amount of inhibitor. You can even predict if hydrate is melting or not. Give you excellent capability. If you are interested, if you are happy to discuss more, this is me working on a prototype HydraSense. And these are some of the devices. This is some of the result. If you want, I can show the, see that, methane, propane. I don't know, can you hear the noise, the sound? Here now, we, this is the final. Yeah, thank you very much for your attention. I really very much appreciate your time, and I hope you wasted your time. Did not waste your time. I appreciate your attention. If you have any question, I'm here. Any question? Okay. Please do not hesitate